Hello and welcome to Ask Your Academic. Today's session will cover MSc Stem Cell Engineering for Regenerative Medicine, and we're joined by our programme lead. We'll do our best to answer any questions that you have, and please use the chat box to submit any further questions too. And we are recording the session, so please don't panic if you miss anything. We will share it shortly afterwards. So Catherine, would you like to introduce yourself and give us a bit of an overview of the MSc?
Sure, Sai. So, hello, people. I'm Dr. Catherine Berry, and I work at the Glasgow University. And I run the master's program just outlined there, so Stem Cells Engineering for Regenerative Medicine. So, my background is in stem cells and regenerative medicine now for 20 years at Glasgow. And we work in a centre called the Centre for the Cellular Microenvironment within the Advanced Research Centre, which is a new building in Glasgow University. And within our centre, we have a group of different people. So we have myself, I'm originally a pharmacologist turned bioengineer when I did my master's programme back in 1996 when I did my master's. And we work with lots of different people. We work with clinicians, we work with physicists, engineers, we work with chemists, we work with cell biologists, geneticists, and together we form a centre which focuses on regenerative medicine using stem cells. So this program came about because we run a lot of undergraduate courses and we have PhD students, but we didn't have anything in between linking the students. So I decided to run this master's program since 2019. And we welcome lots of different students from different backgrounds, whether they're medical, whether they're engineering backgrounds, biotech backgrounds, different backgrounds that are interested in stem cells and regenerative medicine. And the program itself is 180 credits, which is pretty standard for most master's programs. And it's divided almost into three sections. So 2/3 of it are taught masters, where you'll have different courses. And out of those 120 credits, you have 90 credits of core courses, which courses that you have to do, they're compulsory. And then you'll have optional courses for the remaining 30 credits, a 10 credit and a 20 credit. And depending on the interests you have, you can go down different routes, whether that's technology transfer, whether it's emerging viruses, genome editing, or whether it's omics technologies and things like that. And then the final 60 credits to make up your 180 is in your final third of your master's program. And that will be a research project with us in the centre that I just described to you. And that will be a wet lab project where you gain experience working with different researchers in different groups. And most of the researchers you will have met from the taught courses that you have. So you should have a good idea of what those people do and what kind of project you'll get.
Ah,
So
nice.
that's the overview of the whole course.
Thank you. You've touched on a few little things, so it would be nice to expand on them. So, in terms of the classes, whereabouts are they typically held? I know that will be subject to change with timetabling and things like that.
Yeah, so the classes are all on campus and they're across different buildings. So you'll get very frequented with most of University of Glasgow campus when you get here, but all of it is on campus and all of it's in person.
Perfect. And you mentioned the research project. It is such a big part of an MSc. Can you tell us a bit about the process for choosing this a topic, a supervisor?
Sure. So within your semester two, your second semester, which runs after Christmas, so January up until Easter, sort of April time, during that time, we release a list of projects. So, if there's 15 students, it's 15 projects, 20 students, 20 projects. And you get to look through all of those, and then you get to submit your favorite five. We used to do three, but I think five's better. So you get more of a wide choice. And then each student can then select their top five, and then they'll get allocated a project. And they usually get at least the first, second, or very occasionally third choice. But I do need to say, I always remind students, including this year's cohort, who are just about to do this just now, I always remind them that it's not always about the exact project you're doing. So try not to be blinkered about one topic because you're coming into a busy research group. And it's really to give you the experience of being in a research environment. Regardless of the project topic or perhaps the cell type you're working with, or the hydrogel you might be making, you'll be getting really good experience working in a busy research group, going to seminars, joining research group talks, even joining the lab rota for cleaning, as well as doing all the kind of research, the different assays you'll be doing, the microscopes you might be using, the different techniques. And that's what you want from a master's project. You want to have a good range of techniques and experiences. So try not to be too blinkered about the actual exact project you're doing.
Yeah, I think that's really good advice. And I think students are sometimes surprised about the difference between an undergraduate degree and a postgraduate degree. Like there's less maybe contact time. So how much time are students expected to do kind of out with the taught elements of it?
Yeah, so the taught elements, it starts off, I always see the students starting off because it starts off slowly and then it ramps up to getting busy. So I always say to them, try not to get a false impression because it is a full-time course. So you will be busy. At the very beginning, perhaps you won't be, but that's good because you need that time if you're moving to Glasgow to settle in, get your accommodation, work out your social networks, find the university, get around the campus. So a good couple of weeks of doing that, and then you get familiar with everything, and then the workload starts to increase a bit, and that's when your assessments and things like that will come in. So it does come in, but it's a busy course.
Yeah, and I think people sometimes forget that it's a full-time master's, so it's not just as much as a couple of hours class time each day. You've got that time out with to do your other things.
Yes, that's right. Yeah.
And in terms of the assessments, what sort of assessments can students expect?
Yeah. Excuse me. So it's really good in terms, there's a big range of assessments because students are good at various things. Some students are very lucky and they're very good at all things: exams, written tests, oral presentations. So what we do is we assess students across a range of techniques. So for example, for written assessments, you'll get everything from an essay to write, to a lab report, to experimental plans, research plans, to class tests, as well as exams that you will sit in person. There's a couple of courses, particularly the 2 engineering 10-credit courses that are compulsory, that you do have in-person exams for those. But then we also assess, we give the students opportunity to learn how to do presentations. So these can be standard PowerPoint presentations like we're kind of doing now, which can be individual where you're doing it yourself, or you work in a group as well, because that's quite a skill, being able to work with other people. And if you're working in science, you will always work with other people. It's a crucial skill to have. And that's giving general presentations using PowerPoint. But one of the courses I run, we also do a poster presentation, which is where you design your own poster just 2 of you work together on a specific topic that you choose based on regenerative medicine. And I'll print out the poster A0 size and I'll set up a sort of almost like a science conference. So you have the opportunity to present your poster in the same amount of time you get at a science conference. And then you can present it and take it home afterwards for you all. But so it's good. It's a range of different assessments, which will hopefully teach people to be able to write in different ways, assess the literature in different ways, and present orally in different ways as well.
Nice, and it gives you a chance to learn different skills as well, doesn't it?
Definitely, yeah.
And you mentioned practical work. What sort of practical skills will students gain?
So there's different courses. Some of them don't have practical work associated with them and some do. So some of the core courses that you have do have some practical skills involved. So because we take a range of people, this is a stem cell engineering course. So we get biologists who are very familiar with cells and we get engineers who are not, and vice versa. We sometimes get engineers who are very familiar with engineering concepts but don't know much about cells. So one of the first courses you do, molecular research skills, is to kind of put everybody at the same playing field in terms of thinking about cells and DNA isolations and that kind of thing. So you'll get some lab time with that. And there's a few other courses as well, have some lab time as well associated with them. But the majority of your practical work will be a 12-week project that you'll do in semester 3. And that's when you really get involved in the lab work and the lab environment.
Nice. And you mentioned there that students have got different backgrounds. So is there anything that students can do before they start their MSc in September time?
Yeah, there's not a lot, to be honest. No, and we welcome people with different backgrounds. That's the whole concept, really, of the course. So we are aware that some people may not have the engineering skills. It's minimal engineering, but it's enough. You need to have the concepts. If you think of your body, the tissues that we look at, it's regenerative medicine, it's stem cell engineering. We generate tissues in the lab, well, models of tissues in the lab. For 3D environment. So we use different 3D polymers to make gels, we then put stem cells into, so they're happier in those situations than they are when they're cultured in a monolayer. So people have to be able to, students need to understand the concepts of 3D tissues and how scaffolds and things like that work in regenerative medicine. as well as biophysics of cells and systems is another course that we have, which is to understand how different tissues link up and just to understand the engineering concepts of that. So we're used to a mix of backgrounds, so that's absolutely fine. And in terms of preparation beforehand, some students do often get in touch with me. And what I'll do is I'll send them a couple of papers to look at, but they're just for your own enjoyment, might not be the right word, but your own reading, personal reading at home with a cup of coffee, just to see, okay, this is the concept of the course. This is the sort of thing that we'll be doing when we come to our third year. I've also got a couple of video clips I sometimes send out to people of work we've done in the past that's been on. There's a couple of BBC News articles, things like that, that can show you the type of work that we do in the centre as well, which can be quite nice for people to see a little bit of the background of what we do. So if you want that, get in touch.
Yeah, and it's quite nice to be able to do that when you've got the time before you've got all the academic stuff starting, isn't it?
That's right.
And the last question I've got here, it's about careers. So what kind of jobs do students go on to typically after they graduate?
Yeah, that's a very common question. So it's a range of jobs, really. I'd say looking at the I'm in touch with quite a lot of the students from before, still now, and some of them are actually doing PhDs here. In fact, it's nice because some of the first ones that did do PhDs, which we had available at the time, have graduated now with their PhDs, so which is really nice last summer. So I'd say probably about 60% go on to try and get PhDs. Sometimes I always chat to the students at the beginning and say, what do you want from this master's? What do you want to do afterwards? And it tends to be about 30% want to do PhDs, and that tends to increase as the year goes on, as they get more interested perhaps in the potential of doing more research based learning. Then others tend to go into industry. So that's perhaps a competitive route to go down, but I'd say about 30% go into industry. So I'd say about 60 do PhDs, about 30% go into industry, and another 10% go into various things, whether that's teaching jobs, whether it's into places like the NHS, different things. Yeah. Sometimes science communication as well. So it's variety. Yeah.
But that's quite nice, isn't it? Because I guess that you get different skills that you can then world your oyster.
I hope so. Yeah. It's a
It's actually interesting
at the moment, but it's
But it's interesting the PhD route that you mentioned, that not maybe everybody's that interested in it, but as they go through. So I suppose that's a testament to the teaching, isn't it? That there's clearly that interest there that's that grows.
I think so. And I think I do tend to push it a little bit, because I think some students come and start the masters and they might think, oh, I would like to do a PhD eventually, but they don't want to commit to it now. And I try to say to them, well, if you want to do one for the following year, you need to start thinking about it now, even though if you don't feel ready. Because if you try and apply the following year, then there's not many advertised. A lot of PhDs for 2027 tend to start in October, and the adverts come out January, February time. So I make sure I meet with the students and give them a session or two on what a PhD is. And so perhaps I encourage some that maybe weren't going to before. But I think it's good to be aware that if you want to be competitive, you want to apply for a good one, you've got to prepare early. And, I'm happy to meet students and talk them through how to apply for a PhD. And I also give mock interviews and things like that for students that have an interview for a PhD place. So perhaps I push that more than I should. But I think it's a really, if students are interested, I think don't put it off. Don't wait another year. Apply now and see if you can get anything.
Yeah, I think that's really good advice. And it's really good that support's there if people are interested, that they can get the help with the mock interviews and things. That is us covered all of our questions that have been submitted, and there's nothing came through in the chat box. If you do think of any other questions, please don't panic. You've not lost the opportunity to ask them. We've got our website, our email address on the web page for the programme, so please do get in touch if there's anything on your mind, and we'll do our best to answer. Catherine, thanks very much for taking the time out of your busy day to answer all our questions.
Thanks,
and hopefully we'll see you all come September time. Thank you. Bye-bye.
Bye.